Today we're going to talk about a major component in aggregate expenditure, and we're referring to the component called household consumption. In the United States, about 60% of the expenditure is based on consumption alone. So in this video, you're going to understand the definition of household consumption, and you are also going to learn mathematically how to calculate the total amount of consumption an economy has. So what is consumption? In the most straightforward manner, consumption is defined as the final purchase of goods and services by individuals or households. Now, it does not include any of the three following. It does not include work-in-progress goods, which are, maybe raw materials. It doesn't include investment products. And the next thing it doesn't include is imports. Now, the reason why imports are not included is because it is actually value flowing out of the economy. So we know that aggregate expenditure equals to income at equilibrium. So while import is flowing out of the economy, it doesn't become income to us. Therefore, imports is not a part of consumption. I'm now going to introduce to you the concept of econometrics. Now, econometrics is not part of your syllabus, but me explaining this to you will help you to understand macroecons at a much better level. In a nutshell, econometrics is the application of math and stats to economic data. And for the purpose of this video, I'm not going to talk about statistics because I think it's just going to piss you off. So you can relax. There is a level 200 unit called Elements of Econometrics. So if you're interested, maybe you can choose that for your next year's units. So with econometrics, you actually give an empirical content to economical theory or concepts. So what this means in the English language is that you actually have some sort of a numerical evidence to support certain economical concepts or theories. So this brings me to how economists generate functions for consumption, investment, government spending, and net exports. So they use what we call an econometric function. So econometric functions are all about relationships, and how this works is you take whatever variable you want to estimate. So in this case, we're going to talk about consumption, and we're going to call that the dependent variable. And it's called the dependent variable because the value of this variable depends on things like your parameters as well as explanatory variables. So in simple summary, the explanatory variables and the parameters are the ones that affect the dependent variable. Therefore, your dependent variable is a function of the two things that you see on the right hand side. So the dependent variable can be your consumption, investment, government spending, or your net exports. So we're trying to estimate these components. So the relationship between the dependent variable and the explanatory variables are what we call economical relationships, like price and quantity, for example. And the parameters can be defined as the quantitative effects that the explanatory variable has on the dependent variable. If you're still confused at this point, not to worry. Just let me give you a simple example of an econometric function, which is y equals to beta naught plus beta 1 times x. So y over here is the dependent variable, beta naught and beta 1 are your parameters, and x is simply going to be your explanatory variable. I believe that you're starting to see that this is similar to a linear function, because when x is equals to 0, y is equals to beta naught. And when x is going to increase by 1 unit, y is going to increase by beta 1. So I believe you can see that the parameters beta naught and beta 1 give a quantitative effect to x and y. And I can actually plot this econometric function on the graph. So I'm going to have a upward sloping curve because the value of beta 1 is positive. So the blue line over here is the econometric function, and as you can see, the y-intercept is going to be beta naught, and the gradient of this curve is going to be beta 1. So this is clearly seen as a linear function, and that is how econometric functions work. It's very simple. So now that you understand how econometric functions work, we will now learn how to estimate the total amount of consumption in an economy. So the consumption function is defined as such. Total consumption is equals to C0 plus C1 multiplied by YD. And YD stands for disposable income. As you can see, total consumption is the dependent variable. C0 and C1 are your parameters. And disposable income happens to be your explanatory variable. So disposable income is simply your total income less the taxes that you pay to the government. So far so good. Let's break this function down into two portions. So the first portion is what we call autonomous consumption, and the second portion is what we call induced consumption. Now I know these are big words, but you just gotta relax. I'm gonna explain them in just a short while. It's actually not that difficult. So autonomous consumption actually refers to C0, and the definition of this is even simpler. Autonomous consumption is basically the amount of consumption that is not influenced by disposable income. And obviously, induced consumption actually makes up of C1 multiplied by disposable income, and this is the amount of consumption which is influenced by the level of income in an economy. And more specifically, we're talking about disposable income level. I'm going to break down induced consumption into two further parts. You have your parameter C1 and you have your explanatory variable disposable income. So let's start with C1 first. I know you know it's a parameter, but there's a more formal definition for it. C1 is actually your marginal propensity to consume. So what is this marginal propensity to consume? It is basically the percentage or the proportion of your disposable income that you are going to spend. And obviously, you cannot spend more than what you earn. So that's why C1 will take the value of between 0 and 1. So if you're going to take the number 1 minus your MPC, what do you think you're going to get? Whatever you don't spend, you are going to save. So therefore, 1 minus your MPC is going to get your marginal propensity to save. And of course, your MPC plus your MPS should sum to a value of 1. I mean, that's all your money, right? It's 100% of your disposable income. Looking at disposable income into greater detail, we know that it is income after your tax, but you have to know that it is also income after transfers. So what the hell are transfers? Transfers are basically support to or from the nation. So depending on how rich or how poor you are, you may have to give support or take support from the government. So if I were to translate English into math, what you will get is that disposable income equals to Y minus your taxes plus or minus your transfers, which most of the time we would denote with TR, but it could be other things. For the sake of simplicity and for your exams, let's just assume that transfers is going to be equal to 0 unless the question in the exam paper states so. Now, taxes can be either in a form of a lump sum. So if it's a form of a lump sum, we denote this tax as a capital T. And it can also be in a form of a proportional tax, which means a percentage of your income. So we're going to denote this as a small letter p. So the tax payable, if it's proportional, it will be T multiplied by Y. For example, maybe 0.3 of your income. So this would be a tax rate of maybe 30%. Therefore, in summary, to calculate my disposable income for a lump sum tax, it is basically YD equals to Y minus T. Very simple, very straightforward. But what if it's a proportional tax? So a proportional tax is the same thing. You take your income minus your total tax payable, which is T times Y. You can actually simplify this into bracket 1 minus T, close bracket times Y. So let me just explain to you 1 minus T. So if the tax rate is maybe say 30%, and I have 100% minus 30%, which is 70% of my income left. So how I got 70% times Y is simply taking 100% minus 30% times Y, which is also equals to 1 minus 0.3 multiplied by Y. So that is how the logic of 1 minus T times Y came about. So let's just add this into our consumption function and see what it will look like for a lump sum tax as well as a proportional tax. So for a lump sum tax, total consumption is going to equal C0 plus C1 multiplied by bracket Y minus T. So this is very simple. Now let's take a look at the proportional tax. Total consumption is going to be equals to C0 plus C1 multiplied by Y minus T times Y, which can also be simplified into this particular function that you see right here. Now, in the exam, if there's no mention of whether you should use lump sum tax or proportional tax, your default should always be your lump sum tax because this is the easier way out. you're not going to confuse yourself. So you're actually done learning the consumption function, but in Quickienomics, we always want to get ourselves ready for all kinds of shitty scenarios that the examiner can throw at us. So we're going to talk about some variations of the consumption function. So what if there is an income gap between the rich and the poor in this economy? The first thing that you will need to assume is that there's going to be different marginal propensity to consume for the rich and the poor. And the assumption is going to be simple. Basically, the marginal propensity to consume of the poor is going to be more than the MPC of the rich. That's why the rich is richer than the poor, right? It's because of their different spending behaviors. The rich tend to save more than the poor. Therefore, C1 for the poor is going to be larger than C1 for the rich. And there will be a population divide because the rich is going to earn a proportion of the income. Let's assume that the rich earns alpha percent of Y. And the poor is going to earn the rest of that income, which is 1 minus alpha percent of Y. So if I draw a simple pie chart to represent total income, I can actually segment the rich from the poor. So let's say I segment this small little portion to be alpha, which is what the rich earns. Then the rest would be the poor's income. Or, it could look something like this, where alpha is a larger portion of the total income. This occurs when the income gap in an economy becomes too wide. So you might have 10% of the people earning 90% of the income. So the rich will be earning an income of alpha multiplied by Y. So let's calculate their disposable income when there's a lump sum tax. It is basically alpha Y minus T. And in the case of a proportional tax, it will be alpha Y multiplied by 1 minus T. So you see, it's quite straightforward to calculate disposable income now. So for the poor, their total income is 1 minus alpha times Y. Therefore, disposable income for lump sum tax is going to be this, and for disposable income for proportional tax is going to be this. Okay, let's take a look at the consumption function, shall we? Before that, just let me zoom out a little bit so that you can see better. Let's start with lump sum tax. So total consumption equals to C0 plus C1 for the rich multiplied by alpha times Y minus T. And you gotta add C1P multiplied by bracket 1 minus alpha times Y minus T. Take note of the brackets, make sure your Bodmer's rule is all there. So this portion stands for the rich induced consumption, and this portion here stands for the poor people's induced consumption. You might be wondering, if we're going to split up C1, why don't we split up C0? Well, there's no point. If you're going to split up C0 into alpha and 1 minus alpha, you're just going to get back C0 if you're going to expand the brackets on this equation. So as you can see, we have actually used this disposable income right here into this consumption function. So let's take a look at the proportional tax version. It's going to be very similar to what we just did. What you can do is to just take the disposable income, which is in the orange branches above, and copy it down into this consumption function, add in your marginal propensity to consume for the rich and poor. So it's really just a plug and play kind of thing. Once you identify your disposable income, I think you will realize how easy it is to construct your consumption function. So what you can do as a safety measure is to confirm that you've got the disposable income correct. So what I'm going to do is I'm going to add up both the disposable income for the lump sum tax. I'm just going to open up the brackets, and I'm going to realize I'm going to get Y minus 2T. Now this is correct because I know that the economy will be taxed twice for two different kinds of people, right? Two different groups, the rich and the poor. Therefore, when I get Y minus 2T, I know that I have properly defined my disposable incomes. I'm going to do the same for my proportional income. I'm going to add up both the disposable incomes. So what I'm going to get is, as you shall see, Y minus T times Y. So this is correct because the entire economy will be taxed a proportion of their total income. Okay, I hope you're ready to take this up a notch. We're going to keep all the scenarios. We're going to add in an extra scenario whereby there's going to be a transfer of income from the rich people to the poor people so that there will be a smaller income gap. So let's start with a lump sum transfer of the rich income to the poor, and we're going to denote this lump sum as TR. And we're also going to assume that there is lump sum taxes in this economy. So your consumption function is going to look something like this. You have your standard C0, okay, C0 plus your induced consumption for the rich. You're just going to minus TR from the disposable income and your induced consumption for the poor, and you're going to add TR to that disposable income. So this is the lump sum transfer that's happening right here. So as you can see, it is underlined in blue. I'm going to go a step further, and I'm going to extract the transfer from the bracket terms. And what I will get is this line of equation here. So as you can see, due to the lump sum transfer from the rich to the poor, there is an overall increase in total consumption given that the MPC of the poor is more than the MPC of the rich. So this is a good thing, right? Higher consumption means higher expenditure, which also means higher income. Now let's take a look at the proportional tax version of this transfer scenario. So what I'm going to do is I'm going to deduct TR from the rich people's disposable income, and I'm going to add TR to the disposable income of the poor people. So I'm going to get the consumption function which looks like this. And again, I'm going to extract the transfer out of the bracket terms and form a new line of equations. And what I've noticed is that the overall consumption would also increase due to the rich transferring a lump sum of the income over to the poor. We're now going to move on to a more complex situation whereby the transfer, instead of a lump sum, is now a proportion of the rich people's income. So the rich people are going to give a percentage of the income, say maybe B% of the income over to the poor. Okay, so just let me break it down. So the rich people are going to lose beta, alpha, y. So alpha y is the initial amount of income that they are earning, and they're going to have to give away B portion of this total income to them. So this makes beta, alpha, y the total amount of income that they have to give over to the poor people, right? So let's take a look at what the consumption function is going to look like in the case of a lump sum tax. So let's take a look at the induced consumption for the rich. You have everything that's regular here. Transfers has been replaced by beta, alpha, y. Okay, and for the rich people, you're going to add beta, alpha, y to the end of that disposable income. So this is pretty much straightforward. Nothing really complex over here. It's just a change in the alphabets. If you extract or factorize beta, alpha, y from the bracket terms, what you will see is also an overall increase in consumption. You know what? Go try it by yourself. We're going to move on to the last long consumption function in this video, and this is the case whereby there's going to be a proportional tax, and there's going to be also a proportional transfer of income from the rich to the poor. So this is what the induced consumption will look like for the rich people, and this is what the induced consumption is going to look like for the poor people. So just look at the equation first. I'm going to break it down and explain why this is legitimate. Let's start with the rich disposable income. This is how much they are keeping after giving away beta amount of their income, and this is the taxes that is applied to their income. So you can see that makes sense. Now for the poor, this is the amount that they are earning, and they're going to be taxed on that, right? And what they get is this amount, which is from the rich. So we're going to assume that this is not taxed. This is actually very subjective. The reason why I assume that the transfer is not taxed, because from the government's point of view, my goal would be to increase the spending power of the poor so that they've got more benefits and welfare. So why should I tax on that particular portion of the transfer, right? However, for the purpose of proving that the disposable income has been properly identified, I'm going to add a proportional tax to beta, alpha, y for the poor people's disposable income. Now I'm going to add up the disposable income for both the rich and the poor, and I'm going to let fast hands do all the work. If you need to see the math, just press pause. What you will see is that I'm going to end up with bracket 1 minus t times y. So this goes to show that my disposable income has been properly identified. Finally, after so much algebra, we've come to the end of the consumption video. I hope you've learned a lot from this. I want to thank you for studying with Quickenomics.